Hello students, these are the topic tests that we at Bodhee Prep have prepared for you. The idea of these topic tests in Quant is that once you've covered the basic concepts of a test of a topic, you can check whether you're able to apply those concepts in a test format or not. Do the basic concepts, practice, attempt these tests, and that topic for you is done. Once you've attempted the test, every test has a video with it. The video gives you the solutions to the questions, also a brief analysis of how you could have gone about the test. There are 200, more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description below. So make sure you download the app and make the most of these tests. This video talks about the topic quadratic equation, and this is test number 5 on this topic in the app. Overall, the test I think was moderate to maybe uh, easy to moderate sort of a test, where I think 6 to 7 net correct attempts would give you a 95 plus percentile, and the attempt time also should be somewhere in the range of 20 to 23 minutes. If you look at the questions, for example, question number 1 says, uh, let two numbers have arithmetic mean 9 and geometric mean 4. These numbers are the roots of the quadratic equation. So if the numbers are a and b, it is given that the arithmetic mean, that is a plus b upon 2, is equal to 9. So a plus b is equal to 18. And the geometric mean, that is root of AB, is equal to 4. Taking the square, AB is equal to 16. The sum of roots is 18. Product of roots is 16. Therefore, the quadratic equation will simply be x square minus 18x plus 16 is equal to 0. Sum of roots is minus b by a, so we'll get 18. Product of roots is c by a, we will get 16. Hence, option B becomes the answer. I think a straightforward, easy question. Not more than a minute and a half to solve it. All we have to do is put in the values and get the equation from there. Prayush works in a company where his remuneration for the nth day is rupees n square plus 2. So on the first day he gets 1 plus 2. On the second day he gets 2 square, 4 plus 2, and so on. And is the number of days for which he worked in the company. He does not spend any money for the first 3 days of his job. However, from the fourth day onwards, he starts spending rupees n plus 14 on the nth day. So on the fourth day, he would spend n 4 plus 14. On the fifth day, he would spend 5 plus 14, and so on. On which day would he save more than 100 for the first time? Now, saving is equal to earning or income minus expenditure. Daily income is n square plus 2, and daily expenditure in the same terms is n plus 14. This starts from the fourth day. In any case, on the third day, the earning or the income on the third day will be 3 square plus 2, which is 11. So this will not be 100. So we have to look at a day which is beyond 4. So this becomes the saving. So the saving will be n square minus n plus 2 minus 14, which is minus 12. We need this to be more than 100. So this has to be more than 100. If we simply put the values of n from 10, 11, and 12, we can see 100. If you put n as 10, 100 minus 10 minus 12 will not be more than 100. 11, 121 minus 11 minus 12 will not be more than 100. 12, 144 minus 12 minus 12. This will be more than 100. So 12th day is the answer. Or I can solve the inequality and I can say n square minus n minus 112 has to be greater than 0. Now 112 is 2 into 56, which is 2 into 2 into 28. 28 is 2 into 2 into 4 into 7. 4, 2 the 8, 16. 16 and 7, the difference should be 1. 14. 2, 2, 2, 2, and 7 is what we have. 8, 14. Now here n will be minus b, that is minus of minus 1 plus minus root of b square minus 4ac upon 2, which will be, this becomes 448 plus, so root of 449 plus minus 1 upon 2. Root of 449 will be approximately root of 449. 20 is 440, approximately 21. This will approximately be 21 plus minus 1 upon 2. So this further can be written as 21 plus 1 upon 2 or 21 minus 1 upon 2. 22 by 2 is 11 and this is 10. So greater than zeros will happen beyond 11. So a little more than 11, a little more than, little less than 10. Clearly little less than 10 this is not happening, and therefore the first time this will happen is when we have, oh sorry, I've written it wrong. The values of n or the critical points will be 1 plus root of 449 by 2 and 1 minus root of 449 by 2. 449 will be 21.3 approximately. So 1 plus 21.3 by 2, which will come out to 11.22.3, 11.15. This will be a negative minus 20 by 20.3 upon 2, so minus 10.15. So the critical points will be minus 10.15 and 11.15. More than this and less than this will be the positive values. After 11.15, the first integral value is 12, and that becomes the answer. But I think rather than solving, putting the values made more sense. Therefore, I am saying moderate because solving will take time, 2 to 2.5 minutes to solve the question. Alpha square plus 1 by alpha square are the roots of the equation 2x square plus bx plus a is equal to 0. Alpha and 1 by alpha are the roots of the equation x square minus ax plus c is 0. What is the value of 10 plus b? From the first equation, we can write sum of roots alpha square plus 1 by alpha square is equal to minus b by 2. Also, alpha square into 1 by alpha square, product of roots, is equal to a by 2. Alpha square into 1 by alpha square is 1. So from here we get a is equal to 2. Next, for the second equation, we can write product of roots alpha plus 1 by alpha is equal to minus of minus a by 2, which is a. We know that this is 2 because we've calculated the value of it. Alpha plus 1 by alpha is equal to 2. Next, c. Do we need c? I don't think so. So from here we can write alpha square plus 1 by alpha square is nothing but I can add and subtract 2 from here plus 2 minus 2, and after 2 I can write alpha into 1 by alpha. The value will not change. So basically, if you look at the first part, the first three terms, this becomes the square of alpha plus 1 by alpha. And we have a minus 2. We were looking till for the first three terms, and we have a minus 2 here is equal to minus b by 2. Alpha plus 1 by alpha comes out to 2. So 2 square. 4 minus 2 is equal to minus b by 2, which means 2 is equal to minus b by 2, which means b is equal to minus 4. We have to find the value of 10 plus b. 10 plus b will be 10 minus 4, which is 6 becomes the answer. Again, I think a relatively easy question. All we are doing is finding the value of a, from there alpha plus 1 by alpha, and from there the value of b. About 2 minutes to solve. If the product of the roots of the quadratic equation ax square plus bx plus 1 is 45 and one of its roots is minus 1. So if the two roots are say p and q, it is given that p and q is 45. Also one of the roots is minus 1. Therefore q will be minus 45. Sorry, q will be minus 45 because minus 1 into q is 45. So the roots are minus 1 and minus 45. If the product of the roots of the quadratic equation, this is 45 and one of its roots is minus 1. Which of the following the discriminant? Now from here we can write x is equal to minus 1, x is equal to minus 45 are the two solutions, and therefore x plus 1 into x plus 45 is the equation that we have. So the equation becomes x square plus 46x plus 45. We have to find the discriminant. Discriminant will be discriminant will be b square there is a also. Therefore, the equation will be a into x plus 1 into x plus 45. So we get the equation as a 46ax plus 45a. Product of roots will still remain 45. One of the roots is minus 1, the other is minus 45. So this becomes the expression that we have, and therefore the discriminant will be 46 b square 46a whole square minus 4 into a into 45. 46 square will be 45 square into 45 plus 46. 45 square is 2025. 2025 plus 45 is 2070 plus 46 is 2116. So 2116 a square minus 4 160 180. 180 a square, which will be 6 a square 319. 1936 a square, option C becomes the answer. That becomes the discriminant. Again, the A could be a problem in this question, and therefore I'm saying moderate level of difficulty, about 2 minutes to solve, just to make sure that we fit A in the right place. Find the number of roots common to the equations x cube plus 4x square plus 5x plus 18 is 0 and x cube plus 3x square plus 10x plus 12 is 0. Now here what happens is, if the common roots are, say, if A is the common root, then a cube plus 4a square plus 5a plus 18 should be equal to a cube plus 3a square plus 10a plus 12. For that root a, both the values will be 0 and therefore they can be equated. A cube cancel. 4a square minus 3a square is a square. 5a minus 10 is minus 5a. 18 minus 12 is 6. And therefore a minus 2 into a minus 3 is equal to 0. So a could take the value of 2 and 3. Now we know that when x takes the value of 2 and 3, that is where these two equations have the same value. But we're looking for common roots. Will 2 or 3 be a common root of these equations? Clearly, if you put x as 2 here, this will not be 0 because all the terms are positive. If you put x as 3 here, it will not be 0 since all the terms are positive. Therefore, neither of them are roots. Since they are not roots of the equation, they cannot be common roots as well. So the number of common roots simply becomes 0. The question is easy. The only thing is we might end up marking the answer as 2 because we find two values where the expressions are same. The only thing is we are looking at the roots. What happens is these two values are such that the two graphs are intersecting at the point, but these two values are not the roots. If this is graph 1, this is graph 2, equation 1, equation 2. The 2 and 3 that we get are these points where they intersect, but they are not roots. Common roots would be such where one graph is like this, the other graph is like this. Both of them intersect the x-axis at that point, which is not happening. Easy question, but again, check for roots always. So about 2 minutes to solve the question. If a and b are the roots of the equation mx square plus nx plus p is equal to 0, a plus b is equal to minus n by m, ab is equal to p by m. From the first equation, a cube plus b cube are the roots of the equation 1000x square minus 133x plus 1. So what we can do is we can look at solving the equation and then, or we can put a square, a cube, b cube, and then try to solve. Let us try to solve this equation. If we have 1000x square minus 133x plus 1, we are looking for two numbers which have a product of 1000 and a sum of 133 because the product is positive. 1000 is 2 into 2 into 2 into 5 into 5 into 5 into 5. 10, 10, 10. Now 2 to 2 is 8. Okay. Now if I write this as, so I find two numbers, 125 and 8. 1000 x square minus 125x minus 8x plus 1 is equal to 0. So taking out 125x, we get 8x minus 1. Taking minus 1, we get 8x minus 1 is equal to 0. Therefore, 125x minus 1 into 8x minus 1 is equal to 0. So x is equal to 1 by 125 or 1 by 8. So the two roots alpha cube and beta cube are 1 by 125 and 1 by 8. Beta cube, b cube is 1 by 8 because a cube and b cube are the roots of this equation, which means a is equal to 1 by 5 taking cube root, b is equal to 1 by 2. We have the two roots of the equation, this one. So we can find the value of m, n and p. M, n and p will be, if I write the equation as x minus 1 by 5 into x minus 1 by 2 is equal to 0. We will get x square, or we can multiply by 5 into, we'll get 5x minus 1 into 2x minus 1 is equal to 0. Multiplied by 5, multiplied by 2, cross multiply 0. 10x square, 5x minus 1, 2x minus 1. 2 minus 1 is minus 7x plus 1 is equal to 0. So m becomes 10, n becomes minus 7, p becomes 1. So the new equation that we have is p. X square minus 7x plus 10 is equal to 0. This is nothing but x minus 5 into x minus 2 is equal to 0. So we get x is equal to 5 or x is equal to 2. Since we were able to solve this equation, I got the roots and then worked backwards. Therefore, I am saying probably a moderate question. And depending on how we go about the question, it might be difficult, easy or moderate, but definitely moderate question and would take 2 to 2.5 minutes. What we could have also done was, from here, write a cube plus b cube is equal to 133 upon 1000. A into b is equal, or a cube into b cube is equal to 1 by 1000. From here, we get the value of ab. From a cube and b cube, we try to find the value of a plus b. From there, we'll get the equation or the value of these ratios and then put the values here to get the answer. That process could also have been done. But since this was factorizable, I worked with the factorization and from there got the roots. Ujagar and Keshav attempted to solve the quadratic equation. Ujagar made a mistake in writing down the constant term. Therefore, Ujakar got the coefficient of x correct. He ended up with roots as 4 plus 3. So the sum of roots has to be 4 plus 3, which is 7. Keshav made a mistake in writing the coefficient. He got the constant term correct. Constant term correct. So for him, the product of roots would be correct. He is getting the roots as 3 and 2. So the product of roots has to be 6. What will be the exact roots of the original quadratic equation? We need two numbers such that the sum is 7, the product is 6. Clearly, we can see that the option that satisfies the condition is A and that becomes my answer. Easy question. You would have done this earlier as well or similar questions earlier. And therefore, maximum 1.5 minutes to solve it. Option A. This question says alpha is not equal to beta, but alpha square plus is equal to 5 alpha plus 3. Beta square is equal to 5 beta minus 3. Now, if we look at this, they are similar equations. And therefore, if I write an equation which is x square is equal to 5x plus 5x minus 3 or x square minus 5x plus 3 is equal to 0. I can say that alpha and beta roots of this equation. If alpha and beta roots of this equation, a square minus 5a plus 3 will be alpha square minus 5 alpha plus 3 will be 0. And we'll get the first part. If we put beta square minus 5 beta plus 3 will be 0, we'll get the second part. And therefore, we have a quadratic equation with roots alpha and beta. And therefore, we can say sum of roots. Alpha plus beta is minus 5, minus of minus 5 by 1, which is 5. And alpha into beta is c by a, which is 3. We have to find an equation whose roots are alpha by beta and beta plus alpha. Now, the sum of roots will be alpha plus beta. plus beta upon alpha, which will be alpha square plus beta square upon alpha beta, which will be nothing but alpha plus beta whole square minus 2 alpha beta upon alpha beta. Alpha plus beta whole square is minus 5 whole square minus 2 into 3 upon 3. This is 25 minus 6 upon 3, which is 19 by 3. So the sum of the roots of the new equation is 19 by 3. Product of roots will be alpha upon beta, beta beta cancel, alpha alpha cancel 1. And therefore the quadratic equation will be x square minus sum of roots into x plus product of roots. So from here sum of roots will be minus of b, which is 19 by 3. Product of roots will be 1. This becomes my new equation. Multiply by 3 to get the desired form as per the options, and therefore equation becomes 3x square minus 19x plus 3 is equal to 0. The first part might be a little difficult to, or might take time to, we might take time to comprehend that, how to get alpha plus beta and alpha beta. But the moment that happens, the question then becomes pretty simple. Because of the first part, I'm saying moderate level of difficulty in about 2 to 2.5 minutes to solve. Let m and n be the roots of the quadratic equation x square plus alpha minus 3x minus 4 alpha minus 3 is 0. What is the minimum possible value of m square plus n square? Now, m square plus n square is nothing but m plus n whole square minus 2mn. M plus n whole square is the sum of roots, which will be minus of alpha minus 3 whole square. Mn is nothing but product of roots, which will be minus of 4 alpha minus 3. A in both cases is 1, so no problem there. So this becomes alpha square minus becomes plus alpha square minus 6 alpha plus 9 minus minus plus 8 alpha plus 6. So m square plus n square is nothing but alpha square plus 2 alpha plus 15. We have to find the minimum possible value of this. So what we do is we complete the square. Alpha square plus 2 into 1 into alpha. 2 alpha can be written as 2 and alpha we take out, 1 is left. Write the square of 1, subtract the square of 1 plus 15. These three terms become a perfect square. So alpha plus 1 whole square, 15 minus 1 is 14. The value of m square plus n square in terms of alpha is alpha plus 1 whole square plus 14. What will be the minimum value? Because alpha plus 1 square will always be 0 or positive. To make this minimum, we want this to be the minimum value, which is 0. And at that point, m square plus n square will be equal to 14. So the minimum value of m square plus n square is 14. Option D becomes the answer. Basic maximization, the only point is we should be able to see that we have to minimize the quadratic equation. So I'm saying moderate. Depending on the method that you choose to make it a perfect square or minimize the terms might take time, and therefore about 2.5 minutes to solve. A quadratic function f(x) attains a maximum of 3 at x is equal to 1. Maximum of 3 at x is equal to 1. The value of the function at x0 is 1. What is the value at x10? If the function attains a maximum at of 3 at 1, we can say the function will be of the format a into x minus 1 whole square plus 3 attains a maximum. So what happens is when x is 1, this first term becomes 0 and we get the value of 3. Why do we write 0 a here? Because the generic form is ax square plus bx plus c is equal to 0. There could be a coefficient of a which has been taken out while completing the square. So this becomes the standard form of fx. We've used the first part. It also says that at x is equal to 0, the function is 1. So f0 is equal to 1, which means 1 is equal to a into 0 minus 1 whole square plus 3. So 1 minus a minus 2 is equal to a into 1 square, which is a. So a becomes minus 2. So my net function becomes minus 2 into x minus 1 whole squared plus 3. If we put x is equal to 1, we'll get 1. If you put x is equal to 1, we will get the maximum, which will be 3. We have to find the value of f10. So minus 2 into 10 minus 1 whole squared plus 3, which is minus 2 into 9 square, which is 81 plus 3. which is minus 162 plus 3, which is minus 159. Option B becomes the answer. I think this is similar or almost exactly like a previous CAT question. If you've done practice, you should be able to do this. You would have gone through a very similar question or maybe the exact one. And therefore, solving time but should not be very high. If you're looking at this for the first time, then I'd say it's a moderate level of difficulty question. Now, in terms of difficulty level for the overall test, as said initially, moderate level of difficulty, something easy to moderate. 6 to 7 questions, net correct would be a good attempt. And for those questions, 20 to 23 minutes should be good enough time. If I had to choose 7 questions out of these, my selection would be 1, 3, 5, 6, 8, 10. 6, 7, 8, 10. Which are these? Definitely doing this for the simple reason that two terms, arithmetic mean, geometric mean, and then forming the square. So this would be my attempt for sure. This question you can look at to attempt or not. The only problem is it could be a little difficult to comprehend, and then once you get the quadratic inequality, it should be understood that putting the values is a better option. Otherwise, there is a high chance of making a mistake. I am not counting this. This I would have done basic sum of roots, product of roots, simple terms. This question I would say is a tricky question. It is very easy to miss out the a square part. As a matter of fact, by solving, I also did not write it initially, and therefore this could get you a negative score. Not counting this question. Would have done this straightforward concept. Just the point is check for the values that we get. We should check for the roots. Therefore, counting this question as well. Again, this question because 1000 x square minus 133 x plus 1 I was able to solve. From there, getting the roots was not very difficult, and therefore the question happened. So I'm counting this as well. This question definitely attempting. I have done similar questions many times earlier. This question I'm actually counting as an attempt because a square minus x square plus x square is equal to 5x minus 3 was obvious when I looked at the question. Therefore, I'm counting it as my attempt question. This is a question which I'm not counting because sometimes maximizing and minimizing quadratic equation becomes a problem for me. You could swap between 8 and 9. I would choose 8 over 9 as the easier question. But if you think you're more comfortable with minimizing a quadratic, go with this question. 10th again, because I've done similar questions, therefore I'm counting such a question. In terms of level of difficulty, this would actually be high, or as compared to other questions, probably a high level of difficulty. But since I've attempted a question like this earlier, I'm counting this question. So my attempt, or for me, that my 7 questions would be 1, 3, 5, 6, 7, 8, 10. Some of these questions are outrightly because of familiarity with the question and not because the difficulty that they have on their own, but because the question is seen earlier, the attempt is happening.